Hello, on this video I'm going to show how to calculate the broadcast IP, Netmask, network IP, and the usable IPs based on the CIDR notation, which is this number right here with a /. And to make it easier for you to understand, I'm going to organize the work this way here. On top, I have the IP address with the CIDR. Then here I have the things that I'm looking for. And here I have a table. And then later we're going to see how this table is going to help us. So the first step is for us to look at the CIDR. So the CIDR here is number 28. And the first thing I want to do, I want to fill out the CIDR row here with the number of the bits that I have turned on. In this case, it's 28. Now, just a reminder, IPv4 is made out of 32 bits. So each octet has 8 bits. So you have 8 bits here, 8 here, 8 and 8 for a total of 32. So I want to start filling out the bits that are turned on from left to right. So here I know I have 8 bits. So I'm going to put 8 bits here. 2, 3, 4, 5, 6, 7, 8. Then I'm going to put 8 more. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So at this point, I have 28 bits turned on, and the rest of it I'm going to fill up with zeros. So 1, 2, 3, 4 zeros. All right, so my next step is to convert the IP address into binary. So I'm going to convert 192 into binary. You can do it by hand, but I'm going to use the Windows calculator. So here's the Windows calculator. I'm going to click right here in the menu and then click on programmer. Then make sure you click on decimal and then type 192. And then here I have the binary representation of 192. So I'm going to copy this. And then I'm going to place right here. Then do the same thing with 168. I'm going to copy this number. Then I'm going to put it right here. And the same thing with 100. And then finally 50. So based on these numbers now, we can start getting some information right here that we're looking for. So let's look at the mask first. The mask is the CIDR converted into decimal. So if I convert this number to decimal, I'm going to use my calculator again. This time I'm going to click on binary, and then I'm going to paste here. So I know that this number in binary is 255. So the mask here is 255. Then I know the next number is the same one. So 255, 255. And the last number I'm going to copy and take to my calculator again. I'm going to paste it here. So I have the number 240. So this is my mask. All right. So now let's calculate the net ID. To calculate the net ID, I'm going to do a binary AND calculation right here between these two numbers. So to do an AND is the same thing as doing a multiplication. So if I multiply every bit here, I'm going to have the number 1 because 1 times 1 is 1. Then 1 times 1 equals 1 again. 0 times 1 is 0. Then 0 times 1 is 0, and so on, so on. I'm going to end up with this. I'm going to do the same thing here. So here I'm going to end up with 1, 0, 1, 0, 1, 0, 0, 0. Now, if you notice the pattern, anytime that you multiply a number by 1, you end up with the original number. So I can just copy this number into here, and it's going to give me exactly the same result because I'm basically multiplying every single bit by 1. The last one here is a little special because it has a mix of zeros and ones. So I'm going to highlight this to remind me that this has zeros and ones mixed in. So if I do a AND operation right here, or multiplication, I'm going to end up with a 0, 0, then 1, 1, 0, 0, 0, 0. Alright, so this number right here is my network ID. So I just have to convert this number into decimal, and then I'm gonna have my network ID. Now, if you remember, this number here is exactly the same as this one here, which is 192. So I don't need to convert this to decimal because I already have the number here. So I'm just gonna put it here, 192. And the same thing here. This number is exactly this number here, which is 168. The same thing here, so this is 100. And then finally this one here, I'm gonna have to calculate. So I'm gonna copy this number. I'm gonna take to my calculator. I'm gonna paste it, and then I end up with number 48. So here, my network ID is going to be 48. All right, good. So now let's calculate the broadcast address. To calculate the broadcast address, I need to find out which octet on my CIDR that has a mix with ones and zeros. Well, it happens to be this one here. So this octet only has ones, and only has ones again. So this octet here has a mix of ones and zeros. So for the broadcast, anything to the left of this number will be the original number from the IP address. So I'm just gonna copy the 100 right here, and then copy the 168 here, and then the 192 I'm gonna copy right here. So the number that we're looking for now is this one here. Now, just to review the rule again, every number to the left of this special number will be a copy of the original IP address, and every number to the right of this special number would be 255. Now, we don't have anything to the right here, so we don't have any 255. But now the question is, how do we find this number here? For this number here, I'm gonna count the numbers of bits that I have turned on here on this octet. In this case, is 1, 2, 3, 4. And then after that, I'm gonna come to my table. I'm gonna count 4 from top to bottom. So 1, 2, 3, 4. And then I'm gonna highlight this number. So I have the number 16 here. So the number that I'm looking for here now is going to be the network ID, which is 48, plus the number that I found here, which is 16. And then I'm gonna subtract 1. So I have to subtract 1, otherwise this IP address will go into the next subnet. So this number here is going to translate to 63. All right, so the next question is, what's my first usable IP address and then the last usable IP address? All right, so the first IP address is going to be the net ID plus 1. So I'm just gonna copy here, and then I'm gonna increase to 1 here, so I get a 49. And then the last usable IP address is my broadcast minus 1, so 62. So these two rows here are my usable IP addresses. Now the last question that we're looking for here is for us to find out the size of the subnet. The size of the subnet is going to be 2 to the power of however many zeros that I have here. So in this case I have 1, 2, 3, 4, so 2 to the 4. If I had more zeros right here on the third octet, I would just add them up. So 2 to the 4 translates to 16. So the size of my subnet is 16. However, I lose one IP address for the network ID and I lose one IP address for the broadcast. So I need to subtract 2 from 16, so I end up with 14. So in this case, I have 14 usable IP addresses on the subnet. Now, if you do the same calculation, but you use the number ones here, that would give me the amount of subnets that I can have. So based on that, you know that you can have a very large amount of subnets and a small number of IP address on each subnet. Alright, so let's calculate a new one now. Alright, so next we're going to calculate a new IP address, but now the CIDR is 20. Now, if you notice from the past calculation, we did some conversion from numbers to binary that were not completely necessary. So let's avoid doing any unnecessary calculation now. Instead of starting from the binary number, I'm going to start on the CIDR. So here the CIDR is 20. I'm going to start filling out the 20 bits that are turned on right here in the CIDR.
So my counts 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16,
17, 18, 19, 20. So now I have 20 bits turned on. So now I can continue on with the zeros. So, all right. So now I know that this here is the octet that has a mix of ones and zeros. From the past calculation, we converted the 192 into binary. However, this time I'm not going to do it because for the network ID, I'm going to do a AND calculation between these two here, which is a multiplication, and then any number that you multiply by 1, you end up with the original number anyway. So there's no need for me to do any calculation on any numbers to the left of this special number here, because it's going to be 192 anyway, and it's going to be 168. So I can start filling up some information here already without much calculation. So for the CIDR, which is my mask, I know this is every bit turned on, and I know that this number is 255. I know this is 255 as well. For this number, I need to calculate, but for this number, I know it's 0. Now, for this number here, I need to calculate what the decimal number is, and for that, I'm going to use the calculator. So I end up with number 240. All right, so for the network ID, I can just copy the numbers from the top because, again, anything can multiply by 1, I end up with the original number anyway. So the network ID is 192, 168, and then this number I need to find out. And over here, whatever number I convert to binary right here, I'm going to multiply by 0, and then I'm going to end up with 0 anyway. So I can just put 0 here. All right, so the only number that I actually need to calculate is this one here. So I need to calculate the binary for 150. So this is the binary for 150. I'm going to copy, and I'm going to paste right here. And now I can do the AND operation between these two binary numbers. And remember, the AND is just a multiplication. So here I'm going to end up with 1, 0, 0, 1, 0, 0, 0, 0. And now I need to convert this number to decimal. So I'm going to copy this binary, take it to my calculator, click on binary, then paste here. So I end up with number 144. So this number now is 144. And now my next step is to calculate the broadcast. To calculate the broadcast, I need to know which octet on the CIDR that has a mix of ones and zeros, which was this one here. So this is the number that I need to calculate. So any number to the left of this special number will be just a copy of the original IP address. So in this case, I'm going to have 192, 168, and any number to the right of the special number will be 255. So now I need to find out what number is this one right here. So this number would be the number of bits that I have turned on here. So it's going to be 1, 2, 3, 4. And then I'm going to count 4 from top to bottom on my helper table. So 1, 2, 3, 4. I got 16. So the number here is going to be the network ID, which is 144, plus the number that I found on the helper table, which is 16, and then don't forget to subtract 1, because otherwise you're going to end up on the next subnet. And this number here turns out to be 159. Alright, so the first IP address then is the network ID plus 1, easy calculation. And the last IP is the broadcast IP minus 1, so it's 254. And the last thing for us to find out is the size of this network. So the size of this network is 2 to the power of however many zeros I have, or you can also calculate 32 minus 20. In this case here, I want to have 12, and 2 to the 12 is going to be 496. But then after that, don't forget to subtract 2, because one IP address is for the net ID, the other one is for the broadcast. So I'm going to subtract 2, and I end up with 4094 IP address for each subnet. Alright, so let's do one more. Alright, so the next one is the CIDR 14. Let's start by filling out the CIDR so we avoid any unnecessary calculation. So I'm going to start filling up from left to right with ones.
So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13,
14. And then I'm going to start filling out the rest with the zeros. Alright, so right here I know that this is the CIDR that has a mix of ones and zeros, so I'm going to highlight this. And then from the CIDR I can get the mask, so I know that all bits turned on is 255. And this number here I'm going to convert from binary to decimal, so that gives me 252. Then this number here I know it's 0, and then this number here I also know it's 0. Alright, so the next step is to find out the network ID. So the network ID, we know that from this special octet here, everything to the left would be the original IP address, which is 192. So I'm just going to copy here. And again, it's going to be 192 because even if you do any conversion here from this number to binary, and if you end this with 1, you end up with the original number anyway. And then any number to the right of this special octet is going to be 0, because even if you do any conversion of this number to binary, and if you end this number with a 0, you're going to end up with a 0 anyway, so no need to do any calculation here. So the only calculation you need to do now is for this value. And again, this value, you're going to get 168, convert to binary. So I'm going to do that with a calculator. So this is the value that I have. And now I'm going to do an AND bit operation here between these two, or a multiplication. So 1 times 1 gives me 1, 0 times 1 gives me 0, then 1, 0, 1, 0, 0, 0. And I'm going to copy this number and convert into decimal. So the decimal is 168. And now we need to calculate the broadcast ID. For the broadcast ID, we are also going to look into the special octet right here. So I need to find out this number. And the rule is any number to the left of the special octet is going to be just a copy of the original IP address, which is 192. Any number to the right of the special octet is going to be 255 no matter what. So this is 255, 255. And now in order for us to find out this number here, I'm going to count the numbers of bits that I have turned on this special octet. So I have 1, 2, 3, 4, 5, 6. Then I'm going to come here to my helper table and I'm going to count 6 from top to bottom. So 1, 2, 3, 4, 5, 6. So now this number here would be the network ID, which is 168, plus the number that I found right here on my helper table, which is 4. And then I need to subtract 1. Otherwise, you're going to end up on the next subnet. And this number here turns out to be 171. All right, so now let's calculate the first IP address. The first IP address is the network ID plus 1. and the last IP address is the broadcast ID -1. So I end up with 254 here. So the last question is, what's the size of my network? So the size of my network is 2 to the power of 32 minus 14, which is 18. And then after that, I'm going to subtract 2. And it's 2 because one IP address for your network ID and the other IP address for your broadcast IP. And then once you calculate this number here, you're going to end up with some huge number. All right, so a couple of things here to note about the CIDR. The bigger the CIDR, that means you're going to have more ones right here in this row. And the more ones you have, that translates into a large amount of subnets. However, you're going to have less zeros, and the zeros translates into a small number of IP address on each subnet. So if this number is small, you're going to have a small number of subnets and a large number of IP address on each subnet. If this number is bigger, you're going to have a large amount of subnets, but a very tiny amount of IP address on each subnet. So now the question is, how big and how small can you go here on the CIDR? So let's suppose we have a CIDR 0 right here. So what happens if you have CIDR 0? So if you have CIDR 0, then all these bits here would be 0. And if all of them are 0, that means there is nothing for the subnets. So your entire subnets would be only IP addresses. So that's not possible. So what if you have 1? Can you have 1 here? So in this case, you'd have something like this. So that means you can have a very tiny amount of subnets. In this case, it should be 2. And a very large amount of IP address on each subnet. So 1 would be the smallest number you could have here. Now, how about the other way around? How about if everything here was 1? What if you have 32 here? If you have 32, then every single bit here would be dedicated for the network. So in this case, you can have a very large amount of networks, but no IP whatsoever on each subnet. So that's not possible. Okay, so what if you have 31? Can you do 31 on the CIDR? If you had 31, you're going to have the number 0 right here. If you had the number 0, that means all the ones is for the network, and then this single bit here would be for the IP addresses. Now, with 1 bit, it can only represent 2 numbers. So if it can only represent 2 numbers, 31 would be a subnet where all you have is enough bits for your network ID and for your broadcast ID. So you would not have IP address whatsoever. So in this case, 31 is also not possible. So how about 30? Now, if you have 30, you're going to have something like this. And then you have 2 bits dedicated for your IP addresses. And with 2 bits, 2 to the 2 is 4. So you can have 4 values. And 1 value would be for your network ID, 1 value for your broadcast ID, then 1 value for your first IP address, and 1 for your last IP addresses. So in this case, you can only have 2 IP addresses on each subnet. Now, you could have a very large amount of subnets, but each subnet is very, very, very tiny. So because of that, the smallest number you can have here on your CIDR is 1, and the largest one is 30. All right, so let's calculate one more, and then we're going to be done with this video. So far, we calculated these numbers here based on a CIDR, and we had mixed 1s and 0s on these octets, and then mixed 1s and 0s on these octets, and then the same thing here. But what happens when there is no mixed octets? What happens when each octet is either 0 or 1? If that's the case, then doing the calculations is very, very easy. And those numbers are easy when it's 24 or 16, because if it's 24, then this number will be all zeros and then everything will be 1. If it's 16, then these ones here would be 1s and these will be 0. In other words, there will be no octet that has a mix of 1s and zeros. So let's try the 24 here. My side is 24. I start filling out the bits from left to right.
So 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16.
And then here I have zeros. So there is no place here on the CIDR where the numbers are mixed with 1s and zeros. So if that's the case, this calculation is super easy. So for the Netmask, we know that all 1s is 255. Then this number here also converts to 255 and 255. And then this number here, we know it's 0. For the CIDR, we would convert this number to binary place here, then do a AND with 1, and then we would find out some number here. But because any number multiplied by 1 is the original number, so all the octets where I have 1, I can just copy the original IP address. So here's 192.168.0, and then finally this number here, because it multiplied by 0, then it'd be 0 no matter what. Alright, for the broadcast, any octet that has 1, you just copy the original IP address, so 192, and then any octet that has 0, you're just gonna place 255. So this is 255. Then the first IP is going to be the network ID plus 1, and then the last IP is the broadcast IP minus 1. And then finally the size, we know it's 2 to the power of 8, then minus 2. That gives us 254 usable IP addresses. The point here is every time you have a /24 or a /16 or a /8, calculating your values is going to be tremendously easier than if you have numbers that cause your octets to have a mix of 1s and zeros. Alright, so that's all for this video. Thanks for watching.